here we go, kids. This is day 4. Day 4. I think this is my 4th video for the day. Yay! All right, here we go. We're going to work on Mr. Key. Mr. Key's coming out again. All right, let's see what we got. We got our unit circle. Oh, today we're going to be talking about the sine and cosine function together in equations. Now, there's going to be a little theoretical part of this, and then there's going to be a realistic part of this, and this is kind of the tricky stuff. This is the stuff I warned you about that was going to get a little bit difficult, so make sure you pay attention. Like the first 10 or 15 minutes of this, maybe 10 minutes, will be very theoretical, how we discovered all this stuff. So if you remember correctly, we had this be the unit circle. We called it the unit circle because we made that 1. So the hypotenuse was 1. And by doing so, this is our angle theta. And this is opposite, and this is adjacent. Opposite and adjacent. Now, when we know that the cosine of theta is equal to adjacent over hypotenuse, and we also know that sine of theta is equal to opposite over hypotenuse. Well, if the hypotenuse is just 1, this becomes cosine theta equals adjacent over 1, or cosine theta is really just the adjacent side. So instead of us calling this side the adjacent side, we could say this is really cosine theta. So and then this, of course, then if this is just 1, this is opposite. If this is just 1, then isn't sine theta the opposite side? So this side here would be sine theta. And we talked about that when we talked about the unit circle, and we did a little bit more in depth with that stuff. And we said, okay, we're going to think about the x value being cosine of theta and the y value being the sine of theta. So x represents cosine of theta, and y represents the sine of theta. Well, then if I come back to this triangle I got here, and I know that this side is cosine, and this side is sine of theta, then I get my first trig identity. An identity is something that is going to always be true. And that first thing that you're going to learn is the fact that cosine squared theta plus sine squared theta is always going to equal 1. This one right here comes up over and over and over again. Now, not only does it come up over and over and over again in that form, it also comes up over and over again in one of its many other forms. And let's take a look at those 2 other forms that we're really going to see it. So let's start with the idea that cosine squared theta plus sine squared theta is equal to 1. Well, I can readjust this equation. If I start with this idea, I can adjust this equation by coming through and subtracting sine squared theta. So what do I end up with? And that is cosine squared theta is equal to 1 minus sine squared theta. Now, doesn't that really kind of make sense? If I just bring this over here, it changes sign. So there's another equation that's going to come up a lot. And then if I go back to that idea, let's go back to the fact that we got cosine squared theta plus sine squared theta equals 1. Again, this comes up over and over and over again. Commit it to memory. Tattoo it to your forehead. Look at it in the morning when you're gussing up your old hair. That's what I do in the morning. Just gussy up the hair. We're going to get sine squared theta by itself by moving cosine over. So, oops. Sorry about that. We're moving cosine over. So we're going to subtract cosine squared theta. So sine squared theta is equal to 1 minus cosine squared theta. So what do I want you to have really locked down, just nailing it? I'm going to put it all in purple here for you. The biggest one and the highest one is this one. cosine highest. The biggest one and the most important one is cosine squared theta plus sine squared theta equals 1. But from that, and I'll do it in a skinnier one, we get cosine squared theta is equal to 1 minus sine squared theta. And sine squared theta is equal to 1 minus cosine squared theta. These three come up over and over and over. All right. Now we're going to take this equation and we're going to perform a little magic on it. I say magic because who the heck would ever think about to do this except for mathematicians. So, let me get my black pen out. We're going to start with cosine squared theta plus sine squared theta is equal to 1. Now, would you agree I can multiply or add or divide? As long as I do it by the same thing on each side, I'm okay. So what I'm really going to do here, and you're not going to really understand why probably, but I'm just going to do it. And then I'm going to multiply, I'm going to divide this side, whole side, by sine squared theta. But if I divide that side by sine squared theta, I got to divide this side by sine squared theta. Now on this side, I get cosine squared theta over, you know what? Let me start with the easier one that you guys are more used to. Let me put this back in here. Let me go back to the one that you guys are a little bit more accustomed to. Sorry about that. Oh, what am I doing? All right. So start over. Cosine, start with cosine squared theta plus sine squared theta equals 1. What we're going to do, and if I'd had my blue pen, I probably would have been okay. We're going to divide both sides by cosine squared theta and cosine squared theta. So as long as you do it to both sides, it's legal. This gives me cosine squared theta over cosine squared theta, which I think you guys know what that is, plus sine squared theta over cosine squared theta is equal to 1 minus cosine squared theta. You'll never have to do this work, but the next equation I write is something that you're going to have to commit to memory. Let's do it in purple. This is just 1 plus. Now, what is sine over cosine? It was something I told you a long time ago you're going to have to remember and something you have to keep track of, and that's equal to tangent of theta. But in this case, it's tangent squared theta. And you want to know what 1 over cosine theta is. 1 over cosine theta is secant theta. So here's another trigonometric identity that you have got to commit to memory. 1 plus tangent squared theta is equal to secant squared theta. Got one more to go. Going to do a little more magic. Let me bring back my original, the thing that you just have to commit to memory, and that's cosine squared theta plus sine squared theta is equal to 1. Now we're going to go back to what I was doing before, and we're going to divide both sides by sine squared theta. Well, this gives me cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equals 1 over sine squared theta. And let's get the purple pen back out. This cosine over sine is cotangent squared theta plus 1 is equal to, and 1 over sine is cosecant squared theta. So there's another one that you have to remember. So these two are the most difficult ones to always remember. They always are. So I try to remember that the letters are the closest to each other. So tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared. All right, we're going to have to use that information later on, and this information over here in order to solve our most recent equations. And I think we've got 8 of them to go. Is that how many I got? I've got 10. 10 equations we're going to work on. Nope, I got 8 left. Those are 1 and 2. All right, so here's the problem. Here's the problem. I have both sine and cosine. Now, if you look up here at all this stuff I did, do you see a squared? Do you see a squared? Do you squared, 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 all squareds, all kinds of squared stuff, right? I have something to replace squareds with, not regular old cosine. So when we go to make a substitution using one of the identities from the page before up here, we have to remember that we can only replace things that are squared. I can also replace double angles too, but for the most part, I can only replace things that are squared. So here's what I got. I've got a sine squared that I have to replace. I want to replace it with something that will give me something with just cosine. Something with just cosine. So I come up here and I say, okay, what is sine squared really equal to? Oh, sine squared is really equal to this, 1 minus cosine squared. So, okay, I'm going to get rid of this. And I'm going to say, okay, that's really 4 times 1 minus cosine squared theta plus 4 cosine theta equals 5. I just replaced that with what it was equal to. All right, now I've got a quadratic, and we're going to solve this exactly the way we solved all quadratics. Let's see, we distribute, we get 4 minus 4 cosine squared theta plus 4 cosine theta equals 5. This is negative squared term, so I want to move everything to the right side, so the left side is going to become blank. 0 is equal to 4 cosine squared theta minus 4 cosine theta plus 1. When I moved all that stuff over, that's what I get. All right, now I got a factor. Probably, I'm guessing 2 cosine theta and 2 cosine theta and minus 1 and, minus 1. Oh, multiply, yeah. Oh. Well, these are exactly the same, so this is really 2 cosine squared theta minus 1, but whatever. So they just end up with cosine theta equals 1/2. Oh, all that work to get that. And when does cosine theta equal half? At 60 degrees. 60 degrees. But cosine is positive in the first and fourth quadrant. So it's 60 degrees here and 60 degrees here. So this one, so the answer to this question is 60 degrees and 300 degrees. All right, let's take a look at this equation. I've got sine and I've got cosine. I can only replace squared, so I'm going to replace that with what it's equal to. I'm going to go figure out what that is equal to. I come back over here and I look up at my equations and I say, oh, cosine squared is equal to 1 minus sine squared theta. Well, that's not too bad. So I'm going to replace that. Let me do it in a different color so you see it. I'm going to replace it with 1 minus sine squared theta. That's what this is equal to. I distribute. I get 3 minus 3. Forgot my 3. 3 minus 3 sine squared theta plus sine theta minus 1 equals 0. And just like the last problem, my squared's not positive, so I'm going to move everything to the right side. 0 is equal to 3 sine squared theta minus sine theta. Now, when I put these two together, I get 2, and when it goes to the right side, it becomes minus 2. All right. 3 sine theta. Sine theta, and let's see, minus 1 and plus 2. So this gives me sine theta equals negative 2/3, and this one gives me sine theta equals 1. Now I told you we're going to be going back and forth between sine and cosine. So with the sine, I go, okay, when does sine equal 1? Oh, 90 degrees. Got to have all the stuff from sine still remembered. And then I got to inverse sine. Oh, what the heck? I should have theta with that. I got to inverse sine 2/3. So sine inverse 2 divided by 3. And we're only going to the nearest degree, so that's 42 degrees. So theta is equal to 42 degrees. But sine is negative in the third and fourth quadrant. So I'm not going to use this. I'll start with 90. That's my first one. And I'm going to do 180 plus 42. That'd be 222 degrees. And I'm going to do 360 minus, and that will give me 318. Oh, my answer key's wrong. 318. It's wrong. 1 and 1. Right? Yeah. I don't know what I was doing. I had my head up my keister. Head was up it. All right, here we go. So we're going to replace sine squared with what it's equal to. So it's 6 times 1 minus cosine squared theta. Get used to it. Plus 7 cosine theta equals 8. Going to distribute 6 minus 6 cosine squared theta plus 7 cosine theta equals 8. Everything's got to go to the other side. So it's 0 equals 6 cosine squared theta minus 7 cosine theta plus 2 when we subtract 6. Both got to be negative. Going with 3 cosine and 2 cosine. 2 and 1. That's 5 and 2. That's 7, right? Well, I can't put the 2 here. What is that? What am I, crazy? Doesn't even make any sense. Put the 2 here and the 1 here. Let's see. That's 3. And that's 4. That's 7. There it is. So I get cosine theta equals 2/3. And cosine theta equals positive 1/2. They're both positive, so our answer, do we already have a 2/3, by the way? 2/3 was 42 degrees. So theta is equal to 42 degrees here. I don't know why I have 48 degrees. Inverse cosine. Oh, I can't use 42 because that was sine. This is cosine. Oh, man. Crazy. So inverse cosine of 2 divided by 3. And this is 48 degrees. 48 degrees. In this case, theta equals 48 degrees. And when does cosine equal 1/2? That's at 60 degrees. Now, when is cosine positive? That's in the first. So we're going to keep both those answers. And the fourth. In order to get in the fourth, we do 360 minus those angles. So here are my answers. 48 and 60. We'll subtract and we get 300 degrees, and 360 minus 48 is 312 degrees. There they go, kids. That's really weird. Another mistake in my answer key. My answer key is terrible. All right, whatever. We got to replace the squareds. So we're going to replace it. 15. Let me do it in a different color because I'm kind of bored in that color. You know we're going to blue. 15 times 1 minus sine squared theta plus 2 sine theta minus 7 equals 0. Distribute, I get 15 minus 15 sine squared theta. Remember when I told you a long time ago you should be a good factor? This is why. You don't want to get bogged down in all the factoring that's got to go on here in order to solve this equation. The squared's positive or negative, so we're going to move it over. So I get 0 equals 15 sine squared theta minus 2 sine theta. Let's see, that's plus 8, so minus 8. Just checking to make sure I got my math right. Not that my answer key is helpful. 0, I'm going to guess 5 sine, that should be a 5, sine theta. And 3 sine theta. See, I need to make up 2. If I make this 4, this will be 4 and this will be 2. This is negative and positive. So this gives me sine theta equals 4/5 and sine theta equals negative 2/3. Well, the 2/3 on sine I know I got earlier. That's from up here, above there. That's 42 degrees. 4/5, not sure about that. So let's do inverse sine. See, there's that 2/3 we did earlier. Inverse sine of 4/5. And I get 53 degrees. So theta equals 53 degrees. Now, this one's negative. Sine is negative in the bottom two quadrants. So we're not going to keep the 42, but we're going to use it. This one's positive, so we're going to keep that one. So we'll start with 53. Sine is positive in the top two quadrants. So 53 and 180 minus 53. That's, let's see, 127. Then we're going to come over here and we're going to do 180 plus 42 degrees, or 222 degrees. And 360 minus 42 degrees, which would be 318 degrees. Right? Yay, actually got that one right. All right, children, I think we got 4 left. All right, don't forget, we now have to, don't forget, we don't want these double angle formulas off our formula sheet. Remember, those are the ones that are over here. All right, so now we have to be responsible for any one of these. Now, that's why I said, you know, the sine unit was going to be so much easier than this one, because now I've got 1, 2, 3, 4. We don't do too much with tangent. We're really going to deal with these 4 right now until we get to the tangent unit. Excuse me. So, let's go back. So now I can replace squares or double angles. All right, so in this case, I've got cosine double angle. I've got 3 choices to make. These 3. But I want the one that has just cosine in it. So I'm going to choose this one. So it's 2 cosine squared theta minus 1 plus cosine theta plus 1 equals 0. So I just replaced that with this. Okay, so now I got 2 cosine squared theta plus cosine theta, because these cancel. Well, if I remember correctly, there's a GCF, so we can take out cosine theta. And I'm left with 2 cosine theta plus 1 equals 0. And now I'm ready to work. Cosine theta equals 0. And cosine theta equals negative 1/2. This one I draw my picture for. 90, 270. And for the negative 1/2, I know that theta equals 60. When theta equals 60, cosine is 1/2, but this is negative, and cosine is negative on the left side of the bow tie. So that's 60 here and 60 here. So my other 2 answers are 120 degrees and 240 degrees. 180 minus, 180 plus. All right, kids. This time, I'm going to replace it with just the sine one. So I'm going to replace this with this. So it's 1 minus sine squared theta plus sine theta equals 0. Well, my squared's negative, so I want to move everything to the right side again. 0 is equal to sine squared theta minus sine theta plus 1 equals 0. This isn't too bad. Oh, this should be a 2. It's just about to have, I just have to have a problem. It wasn't going to factor. 2 sine theta and sine theta. And I'm sorry about that. If you go back to the formula sheet, don't forget there's a 2 right here. I forgot it. So both negative and both 1. There's only way to do it is both negative, both 1, 0. It works. Don't worry about it. It works. Wait, does it work? All right, kids. Let me go back. I made a few mistakes. I apologize. Let me go back. So in my effort to rush and get through this problem, I kind of screwed up. So we're going to replace this with 1 minus 2 sine squared theta plus sine theta equals 0. Now we're going to move everything to the other side. And I'm all confused because I think I got these little... So 0 is equal to 2. It's positive now when it goes to the right side. Sine squared theta minus sine theta. This is a positive one. When it goes over there, it's minus 1. I made those like 4 dummy mistakes there. That's craziness. My factoring's not very difficult. 2 sine theta and sine theta. This will be minus 1 and this will be plus 1. Because this makes negative 2 and positive 1. I got to ask myself that because I've been making so many mistakes. So this one gives me sine theta equals negative a half. Now it's like, okay, I got it, Krause. I got it. Sine theta equals 1. Sine theta equals 1. Here, right here, 90 degrees. And negative a half. Sine theta equals a half at 30 degrees. But where is sine negative? Sine is negative in the 3rd and 4th quadrants. So here are my answers, kids. 90, 210, and 330 degrees. Because that's what this one is. 360 minus, 180 plus. 2 left, children. Then you're done with me for the day. Okay, so I only have one option here. I only have one option for sine theta, and it's this. I have to replace sine theta with this. 2 sine theta. This is another one of those ones you're going to see on the test. Test and difficult. But it's really easy. But easy. So I can only replace this with one thing, and that's 2 sine theta cosine theta. That's what it's equal to. Plus sine theta equals 0. Now I don't have any more squared, so there's no other replacements to do. There's no other double angles to do. So there's no more of that to do. So what I got to do is look at this thing. And look, don't they both have a sine in common? So I'm going to take out the GCF, which is sine theta, and I'm left with 2 cosine theta plus, remember that there's a 1 here, 1 equals 0. And then I've just set them equal to 0. Sine theta equals 0, and cosine theta equals negative 1/2. When does sine equal to 0? Here, here, and I don't even know if I didn't even read the directions, so I keep that. Let's go up and look. Where are the directions? Do not keep it less than. So this one will give us 0 and 180. Cosine is equal to a half when theta is equal to 60, but negative in the 2nd and 3rd quadrant. So that gives us 120 degrees and 240 degrees. Almost done, children. Let me grab a different pen. Get rid of some of this stuff. Let's end with purple. So let's see what we're going to replace. We have a double angle, and we have cosine. So if I've got a double angle, I'm going to go back up here and I'll say, okay, which one are we going to use? Double angle with just cosine. There it is right there. Double angle with just cosine. 2 cosine theta, 2 cosine squared. So this is 3 times 2 cosine squared theta minus 1 plus 5 cosine theta plus 2 equals 0. distribute. I get 6 cosine squared theta minus 3 plus 5 cosine theta plus 2 equals 0. Almost there. 6 cosine squared theta plus 5 cosine theta minus 1 equals 0. Oh, good, it's 1. That shouldn't make it too difficult. So I'm guessing probably 3 cosine theta and 2 cosine theta. 1 and 1, and that's not going to do it. Better change this to 6 and just 1. And 1 goes here. Let's see, this is going to be a positive and this is going to be a minus because it's going to be plus 6 and minus 1. So there we go. So cosine theta equals 1/6 and cosine theta equals -1. Draw a picture. Start max, end at a max. In the middle, it's a minimum. And in the middle is 180 degrees. So that's what we get for that one. 1/6, I have no idea. So we're going to do inverse cosine of 1 divided by 6. And I get 80 degrees. So 80 degrees. It's positive, so I need the ones in the first and fourth quadrant. Whoa, it's weird. So we'll start with 80. We'll go to 180. That's this answer. And now we're going to do 360 minus 80. That would be 280 degrees. Yay! There's our answers. Oh, I have so many mistakes in my notes from last year. It's crazy. All right, kids, that's it. That's all she wrote. That's difficult stuff. I know you have to go home and practice this. You have to get angry with it. You have to get mad with it. You have to figure it out, okay? It's not easy, but you guys can handle this, all right? So that's it. Good luck and goodbye.